Okay, good morning class. So today we look at algebraic fractions, the last part for the work that will be covered in your upcoming cycle test. Okay. So algebraic fractions. The question says simplify. So if you have a major problem with what's going on here, it might be that your problem is not this topic per se. It could be factorization, or it could be your basic understanding of adding and subtracting of fractions. Okay. As we said, this topic is dependent on previous topics. Okay. Right, so with the first one, we've got 21 over x, 21x to the exponent 7 over 7x to the exponent 5. What number goes into 7 and to 21 without the remainder? 7 going to 7 once, 7 going to 21, 3 times. So if you divide it, both bases are the same, you subtract the exponent, 7 minus 5 is. Are you agree with that? Is there any confusion? No. Let's go to the next one. Number 2. Here we've got 3x squared minus 6x over 3x. People cannot cancel this here. The x and the... No, why not? Because there is 2 terms on top and 1 term at the bottom. Can you see that? Must be 1 on top, 1 at the bottom. Okay? So what can be done here? We'll take out a common factor. And what's common here? 3. What are we left with? X minus 2 over. So what can happen now? Cancel. 3x cancels 3x and leaves you with x minus. Number 3. Here we've got x squared minus 9 over x squared minus 3x minus 18. People cannot simplify the x squares here. Again not, because of the multiple terms in the numerator and the denominator. So we need to get it as one term. Okay. So what type of factorization will happen on top? Difference of 2 squared. So what do I get? X plus 3, x minus 3. And this is all over trinomial. So what goes on the line? The factors of 1 with the coefficient of x squared, which is 1 and 1. And then 1 and 18, 2 and 9, 3 and 6. Do we add or subtract our products? You subtract. 1 times 18 is 18, 1 times 1 is 1. Subtract, you get 17. We're looking for 3. 1 times 9 is 9, 1 times 2 is 2. 9 minus 2 is 7. 1 times 6 is 6, 1 times 3 is 3. Subtract, you get 3. And that's what I want. So 1 and 3 goes to the bracket, so it's an x and a 3, and x and a 6. Okay. What about our signs? Plus and minus. Not what the bigger one must be, the sign of the middle term, which is minus. How did I know plus or minus? Because that is negative. If that had to be positive, then we know the sign must be the same, either both plus or both minus. Okay. But what we notice now, x plus 3 cancels x plus 3. Not so. So what are we left with? X minus 3 over x minus. Alright. The next one, number 4. People, what does this mean? A minus x all squared. There are basically 2 of it here. Not so. And if I put a bracket around here, do I change the value of anything? No. So that will cancel 1 over the 2, which leaves you with a minus x over 1, which is a minus. Right, you guys understand? Is there any confusion? Not yet. Okay. Until we put the same sums in the exam. It is as if I never ever taught you people these things. No? As I told you before, seeing somebody else do it, it's easy. You do it yourself, that's where the problem comes. So you must practice. We've got a minus b all squared, which means to say that is a minus b times a minus b. It's exactly the same thing twice. The denominator, what do we have? 3a squared minus 3b squared. Again, can we cancel this here? No. What can be done in the denominator? Common factor of 3. What are we left with? A squared minus b squared. Can this now cancel? No. But what that factorization will happen here? Sorry? Dots again. So that will give you 3 into a plus b, a minus b. So hang on. What do I notice now? A minus b can cancel one of the two of them. Not so. Just to give you an idea for those of you who are confused, that a minus b squared, that is actually a minus b times a minus b. Can you see that, people? So if that was over 3 into a plus b, a minus b, this would have been 3 into a plus b, a minus b. Which then, in turn, cancel, leaves you with a minus b over 3 into a plus b. You guys see that? So let's cancel that. Gives you a minus b over 3 into a plus b. We tend to leave things like this. I wouldn't multiply the 3. Okay? We'll leave it like that. You're not going to do both, you do either. No? Let's go with number 6. What the factorization in the numerator? Dots again. So what do we get? Sorry? X plus 1, x minus 1. And this is all over x minus 1 squared. Again, here's how many of them here? 2. So it's x minus 1 times x minus 1. Okay? So what happens now? X minus 1 cancel one of those two. This now gives me x plus 1 over x minus 1. And I don't need that bracket in, because there's nothing bounding that bracket up. How many terms are here? One term. Also known as what? Polynomial. You got any confusion here? No. Let's do number 7. Here we got 6xy over 3x plus 3y. 6x plus 6y, sorry, over 3x plus 3y. What can be done in the numerator? Common factor of 6. What am I left with? X plus y over. Common in the denominator? 3. What are we left with? X plus y. So what happens now? X plus y is cancels, leaves you with 6 over 3, which is 2. 2 over 1, which is 2. Is there any confusion there? Not yet. Okay. Number 8. But yeah, a squared minus 9 over a squared minus a minus 6. And that's multiplied by a squared plus 2a, and that's all over a squared. What needs to be done first? Factorize. Not so. What type of factorization here? Dots. What type of factorization there? Trinomial. What's the factorization there? Common factor. You guys understand? So what do we get here? A plus 3 into a minus 3. This is all over. Trinomial. The product line goes 1 and 1. So 6. 1 and 6, 2 and we add or subtract? Subtract. 1 times 6 is 6, 1 times 1 is 1. You get 1. What am I looking for? How do I know I'm subtracting? Because the 6 is negative. Okay? So 1 times 3, 3. 1 times 2, 2. You subtract it, you get 1. That's what I want. Not so. So in the bracket goes a 1 and a 2. So it's A and a 2. And A and a 3. Now. What are the factorization in this numerator? Sorry? Oh, my signs. Plus and minus. The bigger product must be minus. Thank you. So what can be done in the numerator? Common factor of A. What are we left with? A plus 2 over A squared. So what can happen now? Cancel, not so. A plus 2 cancels A plus 2, A minus 3 cancels A minus 3. A goes into A once, A goes into A squared, 8 times. Or I could have just pulled a line through the 2. Or you could have said A over A squared is 8. Not so. You got at the back. What are you busy with, Michael? Okay, now you're picking up your pen, yes? But what were you busy with before that? I'm talking to you. What? Your mom is asking you a question. What in the maths class, Michael? Tell your mom you're busy in the maths class. Because if you're not going to get full marks for your next test, then what are you going to say? Or even a good mark, what are you going to say? Your mom is going to say your teachers doesn't know what they're doing. But your mommy doesn't know that you're not paying attention. Come on, man. Right, so what's going on here? There's A plus 3 over. Is that correct? Huh? Look at number 9. Many things happening here, people. You got 3m minus 3p, and that's all over a squared plus 3a plus 2 divided by m minus p, and that's all over a plus 2. So what needs to be done in the numerator here? Common factor of 3. I'm left with m minus p. What's going to happen here at the bottom? Trinomial. So what goes on the line? 1 and 1, 1 and 2. Do we add or subtract? Add. 1 times 2 is 2, 1 times 1 is 1. We add it, we get 3. Not so. And that's what I want is a 3. So in the bracket goes 1 and a 1, so it's a and a 1. And a 1 and a 2, so it's a and a 2. What about our signs? Same sign, both is going to be positive. Okay. Okay, so this is needs to change to multiplication and tumble in times. You all agree with that? So a plus 2 becomes a numerator. And the denominator is minus p. Even if I put a bracket around it, do I change anything? Do I change anything there? So what can be done? Cancel. A plus 2 cancels A plus 2. A minus b cancels A minus b. So what are we left with? 3 over A plus 1. You see that, people? It's 3 over. Is there any confusion at this point? Huh? No? Right, number 10. You've got x squared all over x squared minus 4 divided by 3x minus x squared. And that's all over x squared minus 5x plus 6. Alright, let's look at the first fraction. Can anything happen to that numerator here? No, so it stays there. Here, denominator? Dots. So x plus 2 and x minus 2. Does we change to multiplication, tumble and times? Not so. So this is going to go to the numerator now. What type of factorization here? Trinomial. So it goes on the line. 1 and 1, 1 and 6, 2 and 3. I know you guys can see the solutions immediately. But rather follow this so that when there's a number in front of x squared here, it becomes useful to understand how to do this. Okay? Do we add or subtract our products? We add it. 1 times 6 is 6, 1 times 1 is 1. What's 6 plus 1? 7. We are looking for? 5. Then middle term. 1 times 3 is 3, 1 times 2 is 2. We add it to get 5. And that's what I want. So in the bracket comes a 1 and a 2. So in this case, it's going to be x and a 2 and x and a 3. What about our signs? Same sign or opposite sign? Same sign. In this case, both is going to be negative. This look on top here. We've got 3x minus x squared. Comment of x. So I'm left with 3 minus x. You all agree with that? So is 3 minus x the same as x minus 3? No. So what do I need to do? Swap that around. If I swap it around, what's going to happen? A negative is going to come out. So you're going to make this positive and negative. You all agree with that? So it's going to be negative x into x minus 3. So what's going to happen now? You can cancel. X minus 2 cancel x minus 2, x minus 3 cancel x minus 3. X goes into x squared x times. Or x squared divided by x is x. So what are we left with? X on top and at the bottom x plus 2 and a negative thing. Not so. So what do I have? X over negative into x plus 2. Like that. Or it could be written like this. Or it can be written as the x to the negative on top. All of that is accepted. You see why maths is so easy? So there's many right solutions. Yeah? Or many right ways of writing the same thing. Alright. Any confusion here, people? No, we're halfway now. No? We're doing it in good time. But the sums are getting bigger. Alright, people, number 11. You got 4x squared minus 9. What type of factorization there? Sorry? Dots. So it's 2x plus 3. 2x minus 3. And this all over. What type of factorization in the denominator? Common factor of? Sorry? 3a. I'm left with 2x minus 3. Multiplication. What type of factorization in this numerator? Common factor a. I'm left with x plus 1 over. What type of factorization here? Trinomial. What goes on the line? 1 and 1, 1 and 3. Do we add or subtract our products? Subtract. So 1 times 3 is 3, 1 times 1 is 1. Subtract, you get 2. So in the bracket goes a 1 and a 1. There's an x and a 1 and x and a 3. What about our signs? Same sign or opposite sign? Opposite sign. The bigger one must be negative. So what do you notice? What can be done now? Simplify, cancel. So 2x minus 3 cancels 2x minus 3. A cancels A. Is there anything else that can cancel it? X plus 1 and x plus 1 is. Anything else? No. Now what? What are we left with? 2x plus 3, 3, and x minus 3. You all agree with that? Which now gives us 2x plus 3 over 3 into x minus 3. And this almost look alike, not so, but it's not. So we leave it like that. Okay? The number 12. Look at this numerator, what do we notice here? There's a common factor of 2x. What do we left with? X minus 4 all over. What's the factorization here? Trinomial. So this will give us the product line 1 and 1, 1 and 8, 2 and 4. Do we add or subtract our products? We add. If this is plus, you add. If it's minus, you subtract. But 1 times 8, 8. 1 times 1, 1. If I add it again, 9. What am I looking for? 6. What's 1 times 4? 4. What's 2 times 1? 2. You add it again? 6. So in the bracket goes a 1 and a 2. It's an x and a 2 and x and a 4. What about our signs? Same sign. Both is going to be negative. Okay. What the factorization here? Dots. There's x plus 2. X minus 2 over. What's common there? X. I'm left with. Now what? What can be done now? Cancel. X minus 4 cancel x minus 4. What else cancel? X minus 2, x minus 2. X plus 2, x plus 2. X and? So what are we left with? Only the 2 in the numerator. So it's 2 over 1, which is 2. Okay. Same thing happened over and over and over and over and over. We're just changing the numbers. People, let's look at number 30. What can happen here in the numerator? Common factor of x squared. What am I left with? X squared minus 9 over 2x. This will change to multiplication. Yes? Sorry? Minus 81. Absolutely. I'm already thinking how that will cancel me. Okay. It's like somebody did their work. The rest of you had a good weekend. Okay. So you're going to get 2x, change the multiplication, dump it in times. Not so. It will be 6. Whatever factorization here. Common factor, x. What am I left with? X squared minus 9. Yes? To make another mistake, yes?
X4 minus 81 and x squared can also be dots.
This here? Dots?
The first one.
Yeah? Yes, you can do dots there, yes. But then you see that we said that common factor overrides all type of factorization. So we always do common factor first. Because if you're going to do dots, you're going to get x squared plus 9x and x squared minus 9x. But what do you notice? X is still common. It must still come. You understand? So it's going to be better for you to do common factor first. People, this goes further? Not so? This can factorize further here. And that one can factorize further. So what do we left with? X squared into x plus 9, x minus 9 over 2x times 6 over x into x plus 3, x minus 3. Anything can cancel, people? Anything that can cancel? Yes. 2 going to 2 once, 2 going to 6, 3 times. I think it's the typo on this question. X and x squared gives you x. So nothing else cancels, not so. So what do I have? 3 times x is 3x into x plus 9, x minus 9. And this is all over. Now this x is also cancelled, not so. So what are we left with? X plus 9, x minus 9, and the 3 at the back, which we of course write in front. This is all over x plus 3, x minus 3. I almost think they wanted this to be a 9 here. Okay, so that the difference of two squares can cancel here. Again, that x plus 3 and x minus 3. But because that is a sum, we cannot change it. Okay, but when I look at the memo, you'll see that there's actually a 9 here. Or there's either 9 or there's a 81, one of the two. Okay, so they can cancel out nicely. But in the exam, if you feel that that stuff must be cancelled, please don't change the sum. Okay, to your own stuff. Rule number 14, here we're adding and subtracting of fractions. Okay, earlier on we were looking at multiplying and dividing. Now we're going to look at addition and subtraction of algebraic fractions. People, what do we do here? Here we do something different. We find an LCM. Not so. What's my LCM here? 6. And of the variables, so what I do is I write everything over 1. Okay, so we ask ourselves, okay, so 3x times what is 6x? 2. So you times it by 2. 2x times what is 6x? 3. 2 times what is 6x? 3. Okay, so what I do is I do not multiply out immediately. So I say 2x minus 1 minus 3 into x minus 1 minus 3x into 1. So what happens is the learner always messes up this one here. On the negative and the right negative. So watch out for that, okay? So if you're that kind of girl that wants to go against the grain, you don't want to write it out again, no problem, just watch out for that negative sign. Okay? So what we do is we multiply that in. Now you then get 4x minus 2 minus 3x plus 3 minus 3x, and this is all over 6x. What is 4x minus 3x? Sorry? X. Okay? And x minus 3x? 2x. You all agree with that? It's going to give you a 2x. Negative 2x, yes? And minus 2 plus 3? 1 over 6. Any issues there? Minus 2x plus 1 over 6x. Probably, sure, I don't understand. Okay. Look at number 15. What's your LCM here? What's your LCM? Now the numbers is 2 and the variables is x squared. Not so. So what is your LCM? So here you got 2x squared. So what must 2x be multiplied by to get 2x squared? What must x be multiplied to get 2x squared? What does x squared be multiplied by to get 2x squared? That would simply give us 3 times x minus 1 times 2x plus 3 times 2, which simply gives us 3x minus 2x plus 6. And this is all over 2x squared. Do you have any like terms there? 3x minus 2x is x plus 6 over 2x squared. Can we cancel this here? And then the 2 and the 6? No, because of the addition sign. You all understand? Let's go to number 16. People, if the number, if the variable is written next to it, is the same as writing it on top. Not so. So in other words, this term here is going to be 2 into m minus 1 over 3. You all agree with that? People, what's your LCM here? What is your LCM? 12. All over 12. So what must this be multiplied here by? 2 times what is 12? 6. 8, 3 times what is 12? 4. 4 times what is 12? So of course the numerator must also be multiplied by 6. This must also be multiplied by 4. This must also be multiplied by 3. Why? So that you can get equivalent fractions. Okay. So we got 6 into m minus 4 plus 2 times 4 is 8 into m minus 1 minus 3 into m minus 1. Okay, so what do we do now? Get rid of the brackets. Why? So that we can add like terms. So 6 times m is 6m, 6 times negative 24, negative 4 is negative 24, 8 times m is 8m, 8 times negative 1 is negative 8, negative 3 times m is negative 3m, negative 3 times 1 is positive. This is all over. Now I look at like terms. What is 6m squared and what is 6m plus 8m? 12m. Now 14. 14m. 14m minus 11m. Negative 24 minus 8. Negative 32 plus 3. Negative 29 over. Is that correct? Okay. Number 17. Got 3x plus y all over 2 minus another fraction 3x minus y all over 3 plus 2x. So what's your LCM here? Sorry? 6. That should be over 1. LCM of 6. So the sum is multiplied by 3. Multiplied by 2. Is that multiplied by? So again, it's 3 into 3x plus 1 minus 2 into 2x minus 1 plus 6 into 2x. So what do we do now? Get rid of the bracket. Multiply the 0. So we get the 9x plus 3 times y is 3y. 2 times negative 2 times x. Negative 2 times 2x is going to be negative 4x. Negative 2 times negative y is positive 2y. And 6 times 2x is. It is all over. See any confusion at this point? Now again, people always misses this one up here. Okay? When the negative is also multiplied. They write 2y, but they retain the negative. So watch out for that. Again, we're going to add like terms. So 9x minus 4x is what? 5x plus 12x? 17. Then we got 3y plus 2y. 5y over. Correct? Number 18. What's your LCM here? Ready? LCM 6x squared. 2x. I don't go on like it when you guys write the wrong thing. Alright, so it's 2x squared. That's absolutely correct. Okay. So what must x be multiplied by to get 2x squared? What must, so the numerator also by 2x. 2x multiplied, what is 2x squared? X. X squared multiplied by what is 2x? A squared, sorry. Okay. So we'll get 2 into 2x minus 1 plus x into x plus 1 minus 2 into 3x squared minus x plus 1. So what do we do now? Get rid of these brackets. So what's 2 times 2x? Sorry? yes, it's 2x. Thank you, Michael. I read it as 2 times. Okay, but this you have to get it 2x. So 2x times 2x? 4x squared. 2x times negative 1? Negative 2x. X times x? X squared. X times 1 is x. Negative 2 times 3x squared. Negative 6x squared. Negative 2 times 2x. And negative 2 times negative x. Positive 2x. And negative 2 times 1? And this is all over. Again, I'm looking for like this. So what is 4x squared plus x squared? 5x squared. 5x squared minus 6x squared. Negative x squared. What is negative 2x plus x? X. And x plus 2x? 3x. Negative x. Negative x plus 2x is x. And then minus 2. That's all over 2x squared. People, okay, this can't factorize. Even though this could have factorized, it's not going to change anything at the bottom. But nothing can really cancel. So I would leave the answer like this. Okay, that's correct. Rule number 19. What's your LCM here? So we will look at the lowest common multiple. No? Sorry? A squared, B squared, C. This is A squared, B squared, C. So what must that denominator be multiplied by together? B. What must this be multiplied by? A squared. What must this be multiplied by? A, B squared. So again, it's going to be 1 times B plus 2a times a squared plus 3 into ab squared. What we're going to do now, we're going to get rid of the brackets. So 1 times b is b plus 2a times a squared, 2a cubed, 3 times ab squared, 3ab squared. And this is all over a squared, b squared. Any confusion there? Is that correct? And the last one, of course. What's your LCM here? But numbers, you've got 3, 8, and 12. What's the LCM between 3 and 8? What number does 3 and 8 go into without a remainder? 64? No, 24. Okay, 12 and 24? 24 is of course the LCM. P squared P and P? P squared. Q squared Q? You got 24 P squared. What must 3p squared q be multiplied by to give you 24p squared q squared? 8 q. What must 8p q squared be multiplied by to give you 24p squared q squared? 3p. What must 12pq be multiplied by to give you 24p squared q squared? 2pq. So I got here 2 into 8q minus 3 into 3p plus 5 into p, 2p. Again, you must get rid of those brackets here. 8q times 2, 16q. Negative 3 times 3p, negative 9p. 5 times 2pq. And this is all over 24p squared. Correct? Alright, so this basically brings us to the end of Algebraic Fractions numbers 1 to 20 from grade 9 textbook. Okay.